I'd like to talk to you today about what an aquifer really is. And so I want to give you the classical definition of an aquifer, and then I want to show you some demonstrations just so that you can kind of conceptually see what an aquifer is and think about how you can apply this out into the real world. So the kind of classical definition, the working definition that I use for an aquifer is rock or sediments in a formation or group of formations that are saturated, that have some kind of permeability, and that are able to transmit water in some kind of economically viable way. And so the idea from that is you can think about this glass jar that I have that have gravel inside this glass jar. And so there are rocks or sediments in here. There is pore space between each of these rocks, and so that when I pour water into this jar, it can become saturated. There is a permeability to it, so water can move within this jar. If I was to, for instance, put a straw in and suck on that straw, I could move water through the pore space. And the other thing is that in terms of economics, it would be actually very easy for me to extract water from this jar. And it just doesn't have to be these coarse-grained sediments. We could also have fine-grained sediments like this kind of sandy sediments. And the keys really here are four terms, okay? The first term is that it's rocks or sediments, right? It's a formation. The second is that it's saturated, that it's full of water. The third is that there's some permeability to this. Water can move in the pore space. And the fourth one is economics. You can economically remove the water. And the important thing about the economics is there are parts of the world, for instance, think about the Gulf of Mexico. If you go out into the Gulf of Mexico off the coast of Texas and you go down through the ocean and hit the bottom of the ocean floor, if you were to drill in the bottom of the ocean floor there would be sediments. It would be fully saturated. There would be permeability in those sediments. The thing is that water is salt water, right? And so economically, that water is not a viable source of water, right? It doesn't do us any good to extract that water. So while those are saturated pores, there's no economic value to that. And that's really actually a key concept here. If it's not economically viable, then really in this classical definition, this working definition, it's not an aquifer. So let me kind of show you how that works in practice, thinking about sediments and rocks and saturation and permeability. And I'm going to show you with two examples. I have two different rock types here. This is a granite and this is a sandstone. And I want you to kind of think about which one of these would be a better aquifer, okay? The granite is very crystalline. I'll show you that a little closer. You can see all those wonderful crystals in there. And the sandstone is a little more homogeneous. And actually the interesting thing about the sandstone is when I rub my hand across the face of this sandstone, I can actually feel the sand grains in my hand. So let's start with this granite. Is granite a good aquifer? And so what I have here is I have a bottle of water, and I'm going to spray this water onto this face of the granite, and we're going to see if we can saturate this granite, if it has permeability, and if I could economically extract water then from this granite, okay? So here we go, and you can just watch along as I do this. Okay, so I'm spraying the water, and what you can see, hopefully, is you can see that water just dripping right off the rock and falling onto the floor of my office. Okay. If I let this pause for a second, I can touch it and the outside of the rock is wet, the face of the rock is wet, but it doesn't look like any water is getting into that rock. And so what I see there is it doesn't have permeability. This granite is so tight, right? The crystals are right next to each other, so there's no porosity for that water to kind of get into and fill. Now let's try this sandstone. Okay, so I'm going to take this same water bottle, I'm going to spray this onto the sandstone, and what we see here is that there's very little water dripping onto my floor, and much of that water is actually soaking into the permeability. The rock is becoming saturated, right? And so we have, in both cases, rock or sediment, right? That meets the definition. In one case, I can saturate it. In the other case, I cannot saturate it. In one case, there's permeability where this water is actually moving back into the rock. It's being pulled into the pore space, right? And if I was to drill a little hole in here and put a straw after this rock had soaked in water overnight, I could actually suck water out of this rock. So there's actually an economic value in this. And so when we think about aquifers, right, we think about them being rocks. We think about them being saturated, okay? We think about them having a permeability, and we think about them having an economic value that we can extract that. And if your rock or sediment doesn't have those 4 criteria, then technically it's not really an aquifer. And that's a good place to start to think about groundwater flow and think about how this connects to other aspects related to these kinds of things. What is the storage? What is the medium? What is the rock? What is the aquifer that holds that water? So I hope this helps, and I'd be happy to answer any questions if you have any questions.